Okay, so let's see if we can go through this a little bit faster than we did for the first one. It's the exact same process, so I'll do a wee bit less chatting and yeah, try and follow that same recipe as before. So we do the expansion, we link up our coefficients, we do the k value, the tan theta, tan alpha value, and then write the wave function. So see if you can do that. Feel free to pause the video, try it, and then check the working as well. Okay. So first thing I'm going to do. So this might be quite a quiet video actually, just me working through this. The only thing I'd like to point out there is that I'm moving cos alpha over here and I'm moving sine alpha over here. I'm not switching the x's and the alphas around, I'm actually moving the function. Okay, this is like 2 times 3 times 4, and they're writing that as 2 times 4 times 3. I'm moving this whole function over. Some people think that I'm moving the x's and the alphas, okay? So watch out for that. Whoops. And I would genuinely encourage you to write, try to circle this, to actually circle it. And yet costs are the same, negatives are the same, sign, so they have to be that. Very good, very good. And this question is in degrees, unlike the last one, so I'm just going to have to get my calculator to shift mode and select degrees. So really watch out for that. Definitely, I'd really encourage you to get your own calculator, get used to your calculator. So that's 56.3 degrees. And at this point, you know what? I did it in a different bit last time, but you'd be, it would make sense if you wanted to do it just now. You could say, I'll do the cast diagram. So sine is positive, cos is positive, and tan is positive. So it's the same as before. Sine is positive here, cos is positive here, tan is positive here. So it's in the first quadrant. So it is just going to be this answer. I'm not going to have to change that any. It's just going to be x. But you could do that there if you wanted. Okay. The square root of 3 squared plus 2 squared. So that's 9 and 4. So it's root 13. And your final answer then, just write your wave function. So it's root 13. What was my expansion? It was a cos plus. So it's cos x plus 56.3 degrees. Okay. See a lot faster when I'm not chatting through it. Okay, so exact same process as before. Not come across any negatives yet, so hopefully we'll see one of them soon. But exact same as before. I moved this up here, the same difference really, but you might want to just keep that together. If it was one of these was negative, I'd have to just change this number and the alpha would be in a different quadrant. Yeah. And then the second part is the exact same again. So root 13, 56.3. So root 13 cos x plus 56.3. So we're saying that's our wave function, and we know that's equal to 2 cos x take away 3 sin x. Yeah, so if I went on to Desmos and put in 2 cos x and took away 3 sin x, so this is the wave I would get. And again, 2 cos x, the height of that is 2, the height of that is going to be 3. The height of this one is root 13. Okay, so that's, same as, and that's how much it's shifted. Positive means it's shifted to the left, doesn't it? And we were saying, well, when does this graph equal 3? So on the y-axis, when does this graph reach 3? Well, I just have to say, well, when does this graph, the root 13 cos x plus 56.3, when does that equal 3? I think I might just put that onto Desmos. Give me a sec just to show you. Okay, so yeah, 2 cos x take away 3 sine x. So there's 2 cos x on the blue and negative 3 sine x on the red. So see the negative sine x, it's upside down, isn't it? It's going down the way instead of up the way. And the 2 cos x went up to 2, down to negative 2. If I put them together, I'm just adding up the height of the waves each time. And as you can see, it is like I've got a cos wave that's been shifted to the left, but you can also say there's a sine wave, isn't it? It's a sine wave that's been shifted to the right. Okay, so exactly that's. So we're saying when is this equal to 3? So there's my 3 here. So I draw a line of 3. It's going to be these two numbers over here, isn't it? I'm looking for those two. Yeah, when is this equal to 3? So just do a rearrange. I make sure your calculator is in degrees for this. So I've got 33.7 degrees. Okay, and then before I solve, I have to do my cast diagram. So in this case, the cos value was a positive value I was working out. So cos is positive here and here. So quadrant 1 is just your standard, just your answer, isn't it? In the last quadrant, it's x plus 56.3 equals 360 take away 33.7. So let's solve this one. 33.7 take away 56.3. I'm just rearranging to make x the subject. So x is equal to negative 22.6 degrees, okay? And over here, I'm doing 360 take away 33.7, and I'll take away 56.3 as well. See, 360 take away 33.7, take away 56.3. So that comes out as 270 degrees. It's quite a nice number. So is that within the range that I've been given? 0 and 360, not quite. If I was to draw that out, say there's my 0 here and there's my 360. I've worked out an answer that's over here, so at negative 22.6. And I've worked out an answer over here at 270. So I like the 270, but I don't like this 22.6. It looks a wee bit too low, doesn't it? So I'm going to actually, that's why I drew that, because I've got it on Desmos, don't I? So let's have a look at Desmos. So it looks as if I've worked out this number beautifully. That's the 270 in there. This is, don't worry, this is on a different scale, it's fine. But that's my 270, and I've also worked out this one in here, so that's not factoring like that. Yeah. When I've got 3, sorry, yep, I've worked out this one over here, it's 3, isn't it? So I've worked out this one, and I've worked out this one. So I don't want this one, I want this one. I just have to add on my 360 to get me over here. Yeah, so I've got 2 points, point here and point here, but this one isn't in the range I'm looking for. It should be in this range. Yeah. So all I have to do, I hope I'm not making it more confusing than it should. I'm just trying to show you. I just have to add on 360 to this. So 22, negative 22.6. And that will give me 337.4 degrees. Okay. So just check your limits at the end to make sure they're inside the right bit. And if they're not, you're just adding on 360 or taking away 360. That's as simple as that. Okay. Or adding on 2 pi, taking away 2 pi if it's in radians. I'm quite glad we had that just to show what's going on. But that's the thing, your wave just goes on and on and on and on. So you're not quite sure when you solve it which bit you might solve, this bit over here or this bit. And we're looking for the 0 to 360. So you might just have to change your answer slightly. If you work out these two, maybe you want these two. Take away 360. Okay? And yeah, exactly the same as last time. So I hope you're seeing there's a nice recipe to be followed, and there's a lot of good marks. 7 marks. That took us less than 10 minutes, even with me waffling on. Okay. So next video we will try another one if I can find it.